Welcome. My name is Norman. I'm with itemis, and alongside with Sascha and also involved is Michael. We will present you some updates on the modelix platform and what we're doing there. If anything is interesting to you or you want to reach out, contact us. We have a Slack channel in the MPS workspace. Contact us there, write us an email, whatever you like. And with that being said, let's directly start. Of course, I could tell you, look into the previous presentations if you want to know about the use case or the situation we're in, but I want to give a brief introduction for anyone who might not have heard about modelix or who might not have thought in detail about whether or not web or any other means of accessing model content is relevant to you. So let's consider a simple example where we as language engineers, we use MPS, create some DSLs with which users can create their models. So some experimenter indicated by the Flask would create their own solutions based on the language we do. We store that in Git, all is fine. But as soon as we increase the scope or we change some of the parameters around this, let's say we add someone else who is doing some accounting stuff, that person with a paperclip, or is doing project planning, which is not that detailed of a domain-specific thing, but they do need to organize the experiments done in the lab, right? Of course, we would say give them a solution or give them some way to create those. But after all, these are not technical users. While you might teach the person who is doing experiments and has a technical background how to use Git or a workflow such as Git, these people will most likely be either confused by the tool and be completely out of it. So one proposal for this, of course, is going to the web, and then we get to the point, okay, we not only have one person working on these other input mechanisms or access mechanisms for the models, and then there are several, and then is Git the right choice? Because then we end up with merge conflicts and all these steps, so maybe not, right? And what we do with modelix, or what we intend to provide, is a way to actually share those models between different instances, and this is more than just the storage. It comprises of many parts, right? There is communication from MPS, for example, to some sort of a repository, but also from the browsers or any other client, model client, as we call it. And this is the broad scope where we are in, right? So, and in the past, there have been some confusions what exactly modelix does and solves. Whether or not this last part down here is also in this question. We can talk about that maybe at dinner. But just to make it clearer what we are actually after, we thought within the last 7 months, so this is the time I'm with the project now, what we're actually doing. And we consider ourselves that we provide a collaborative and scalable open source platform for domain-specific models on the web. Meaning what's not said here, but I want to make this clear, we're not a language workbench, right? We don't provide the entire experience one would expect from something like MPS or other tools, but we want to provide a platform which at some point some person might create a language workbench with, but that's not what we're after, right? We want to build the entire building blocks, the small building blocks that make up the entire thing after all. And with that small introduction being done, I would hand over to Sascha, because we would like to get into some practical things first before I tell you more about the, I would say, project part. Okay, thanks.
I will now go a bit into the details of what we have built. The first thing you can even try yourself if you go to our website, modelix.org. There you find this demo button. But if you want to try with your own secret project, you can also install the same components into your own Kubernetes cluster. Basically, you just run helm install. We have instructions how to do everything on our website. But in any case, what you will see is this page. There are two main components. We have this model server where you can store MPS models and synchronize them between MPS instances. But not only, you can also build your own clients and work with MPS models outside of MPS. Then there are these workspaces. We use them to allow you to run MPS instances inside the Kubernetes cluster. And let's have a look what what a workspace is. If you click on workspaces and you see a list of existing ones, if you go to our public cluster, usually for each of your MPS projects, you would create a separate workspace. If you click on one or create a new one, then you get to the page where you can configure this workspace. And if we look closer into such a configuration, currently it's just the YAML file that you directly edit, but of course in the future we build some nicer UI, but currently it makes it easier to add new features until we figured out what features we need for a workspace. But the point is you want to run MPS on the server side and then somehow work with it inside your browser. And of course, you don't want to run an empty MPS project. You want to use your existing projects somehow, your existing languages, to edit your own models. So you can specify a Git repository that contains the MPS project, and that usually has a dependency on maybe the popular MPS extensions library that you can download from our Maven repository. So you can specify that one here if you have a dependency. Or if you have dependencies on some libraries, languages that are not published yet, or your project is not stored in Git, then you can also just upload a zip file and then it's listed here. Once all the files are complete, there's this problem that your Git repository usually only contains source files of your languages. There are no generated classes or source files. So we want to make it as easy as possible to use your MPS project with modelix. So the first thing we have to do is build the languages so you can immediately start working with them. We don't assume that there's any MPS build solution or Gradle script for building these. modelix automatically searches through all the files, tries to find modules and analyzes the dependency, and then it generates this ARN script that you usually generate of the build language. But we have our own generator for that, so you don't have to deal with the build language. And then we run the script to build the languages and prepare it for being loaded into MPS. And because in this step, we also have all the dependency information, we can use that to reduce the required memory of this MPS instance if you enable this flag. Then just removes all the extensions from MPS extensions, for example, that are not used by your project and they just don't get loaded. Once you have configured your workspace, you can click on this Open MPS link, and that starts a new MPS instance inside the Kubernetes cluster. And then you may see this loading screen while you wait for MPS to start up, but we also have a feature to skip this by starting some instances in advance, ready for a new user to get this instance assigned. And then inside your browser, you have your fully functional MPS IDE. You can just send someone a link to such a workspace, and then they can start editing models inside MPS. We only have built all the infrastructure and all the Kubernetes infrastructure. We getting the MPS UI into the browser, that's not something we have built. For that, we use another JetBrains product called Projector. So far this solves this deployment problem that users don't have to download and configure MPS. They just open a link, but another goal is to also simplify the UI and only provide them the tools they need for editing models, and not all the complicated UI elements for language for editing languages that they don't understand, so you can build your own custom UI. For example, if you click on this open web interface, then on the right side there's still this projector-based UI. The only difference is that MPS is running in this special distraction-free mode where it removes everything except the content of the currently active editor tab. So it's still a fully functional MPS on the right side, but on the left side, that's some generated HTML. And this HTML code is generated from inside MPS using our incremental transformation engine that we call shadow models. It's part of MPS extensions. And it's not a static page, but there's some WebSocket connections that whenever there's a change inside the MPS model, then also the view gets updated. So while this is a very generic UI that just looks like a project view, you can also define your own transformations to build something more custom. Once the user is done editing the models, then you usually want to do something with the model. So for example, running the MPS generator and accessing the output. So that's also something you can do from your browser. There's this generate button next to a model. And if you click on that, then you see the generator output can download individual files or everything as a zip file. There's this Git history link. So since you are able to run MPS inside your browser, we thought it's also useful for maybe reviewing pull requests. So you can, if you click on it, you actually don't see a Git history, but you need some way to select two Git commits, and then you can show a diff of the MPS models, which I think is more useful than looking at XML diffs on GitHub. It just shows you, it just opens this MPS diff dialog, makes screenshots of it, and then shows you this page with all the model diffs. And if I enlarge one of them, it's truly just a diff dialog from MPS. There's this last link, model history. So the MPS instance is, so multiple users can have their own MPS instance running this workspace. And when they edit the models, the changes are automatically synchronized between the instances, so they can do real-time collaboration. And this link allows you to show the history that the models server stores during this editing session. And it looks very much like a Git history. We have some commit hash, we have an author timestamp, and under the hood, it technically is very similar to Git, where and just instead of storing files, it stores individual nodes, and commits are created automatically. So there's no commit message here, and your local changes automatically merge with remote changes. So whenever there's a conflict, it's automatically resolved. You don't, the model server, of course, is not specific to workspaces. You can also use it without MPS, or you can run your own, your local MPS on your local machine, not in the Git, not in the Kubernetes cluster. And there you can create your own repositories and also access the history from here. So there's a plugin running inside MPS that synchronizes the models with the model server. This plugin is running in the instances in the Kubernetes cluster, but of course you can install the same plugin into your local MPS, and then it has some UI to add a model server connection, create a new repository or a new branch, and also view the history. This button, this link allows you to manage the running MPS instances. inside the cluster. If your cluster is running out of resources for some reason because there are too many instances, then you can stop them here. And there's also this feature that I mentioned to avoid this loading screen. You can pre-start some instances so that there's an instance ready when there's a new user who needs one. I also mentioned that for running MPS projects inside your inside modelix, you don't need any MPS build solution or Gradle script, and the same functionality is probably also useful in a different context without modelix. So we made the same functionality available via this Gradle script. It replaces the MPS build language, so you can just specify MPS version, the path where your languages are located, and if you want to publish them to some Maven repository, then you can define publications and include your languages here. So far this solves the this allows you to run your MPS projects without having to change or add anything. But we also want to be able to work with models outside of MPS. For example, building your own web application or some services that connect to the model server and then do something with the models, like running a model checker or something like that. So the necessary infrastructure is our model server. There's a model client to connect to it. It's implemented in Kotlin multi-platform, which means it can run inside MPS to synchronize MPS models, but can also run inside the browser. So you can load your MPS models into the browser and then maybe use Angular to build some custom web applications with access to the MPS models. And of course, it's read-write. So whenever you change something in your web application, then you also see the change in your MPS instances. This model client implements an API that's very similar to the S-Node or S-Concept API. It's generic reflective, not specific to any languages. And on top of that, to work with models in a type-safe way, MPS has this S-model language that, where you, for example, have this node type that references a concept. Then it provides some type-safe operations on concept instances. If we are not inside MPS, then we need some other way to get this type information, for example, to Kotlin or TypeScript. And this type model API that's generated. So we take the meta model, the structure model of a language, and then generate some wrapper classes around nodes that allows you to work with models in the same type-safe way as the S-model language does. And then you can use them to build web applications, for example, using Angular. But of course, we all use MPS because we love the projectional editor, and we also implemented an alternative, also in Kotlin multi-platform, so it can run inside the browser. So how do we generate this typed model API? That's one way to do it if you want to generate something out of MPS structure models. Then you can use MPS generator, but that's not what we do. We did that in an earlier version, but now we have this intermediate step of exporting MPS meta models into a JSON file, and then the generators implemented in just some Kotlin code. So it's not using the MPS generator. This has different advantages. This intermediate step, for example, allows you to not just export this meta model from MPS, but also from other tools. So it's more decoupled from MPS. since everything behind it also doesn't require MPS. This makes sense. And we also don't want to generate Java. We want to generate Kotlin and TypeScript. And if you want to generate something else than Java, then it's a bit difficult in MPS. And this approach is a bit more lightweight and flexible. There's also a Gradle plugin for running this generation step. You just specify where to find your languages, and then you can tell it what languages you want to generate an API for. Yeah, and after that's done, you get this is some Kotlin code that works with this typed API. The goal was to make working with models similar to working with models in MPS using this S model language. This is how you would write the same code inside MPS. You can already see something specific to modelix here when loading MPS models into modelix modules, and models just become normal nodes that are of a specific node, and then you can work with them in a more uniform way. Here's this. Here's a feature of Kotlin that we use, extension functions, or an extension property actually. So on a list of nodes, you can navigate to a child link and avoid writing this select many or this flat map, how it's called in Kotlin. Kotlin has very nice features that gets us very close to the convenience of the S model language. And the typed API also does some type conversion on versions on integer and Boolean properties. So I mentioned that we have also built our own projectional web editor because while it's nice to have some Angular application around the editor, you usually still want some projectional editor, or at least you want a web application and embed single expressions somewhere. So that's our goal, to have a projectional text editor that can run inside the browser. And we had an earlier prototype that was running inside of MPS. It looked like this. It's still running on the server side, so the UI is computed inside of MPS, and then there's just some HTML sent to the browser, and all the user inputs, mouse and key events are sent back to MPS and processed on the server side. The only thing you have to do is there's this special web aspect where you can, with this new notation language, define your own editor. So if you want, in this prototype, if you want to build a custom a web-based projectional editor, you only have to implement re-implement the editor aspect, but you can use all the other aspects like the type system or scopes. But if we want something independent of MPS running inside the browser, then this means that we also have to basically re-implement all the aspects that are relevant for the editor. I will show you more about it later, but this, for example, how it would look like. This is some Angular application. I've built this ugly project view. But you can build something more custom. Project view is just some generic way of working with modules and models. And then on the right side, this is the editor that we implemented in Kotlin. So it doesn't depend on MPS, but it can edit MPS models through this model server. This is how you would implement an editor for your language. So you also have some concept and then specify an editor. It's similar to how you would do it in MPS, but this is a Kotlin DSL, and Kotlin has some very nice features that are designed for building such DSLs, and that makes it almost as declarative in MPS. Of course, you don't have an inspector here, but some people see that as an advantage. Here's an example. That's a property cell for the name property of this concept. Here we create a constant cell in curly braces. You can customize a cell, for example, setting the text color. Also, again, Kotlin has these extension functions, so we don't, in our DSL, we don't need these style sheets that you know from MPS, but there's some generic way to build your own abstractions and make them reusable. This is a reference cell, for example. In curly braces, you just provide a string how to render the reference target. The same string is used in the editor, but also in the code completion menu, making it consistent, avoiding duplication. The behavior is always useful if you define an editor for some super concept, but at some locations you want to have extensibility. So the behavior is often used, and MPS is often used to make things extensible. And in modelix, they are just called polymorphic functions. You define a function for some super concept, and for all these subconcepts, you can provide these implementations. And then when you invoke such a function based on the provided parameter, the most specific implementation is selected and executed. In the projectional editor, the only way to actually type something is if it's part of the code completion menu. So everything we need for the code completion is not optional. The code completion menu is absolutely necessary to be able to type something. So we also need the scope aspect. It's also very similar to MPS. We haven't built something special just for some reference on a concept. You return a list of visible elements. Maybe later we will add some special scope language, but currently it's as simple as an MPS. And MPS has also these scope providers, and since we have the behavior aspect, you can you should be able to implement your scopes from MPS also in this language. You can see another aspect that we need for the editor. So the scopes need information about the type of an expression, and the type system language, also no surprise, looks very similar to MPS. For a given concept, you instantiate these inequations, and then the type system tries to find a solution for it. On the right side is an equivalent of how you would write that in MPS. It's truly almost the same. This is how you write this type of. This is how you assign a value to a type variable. Then one last thing about this, about the implementation of the projectional editor. So what the editor in MPS does is whenever there's a change in the model, it automatically updates itself. And it does that by recording dependencies between UI and model elements. And of course, as we build a projectional editor, we also need something like that, but we extracted this functionality into a reusable library for incremental computation. And this is used for all the different aspects for the editor, type system, scopes. But this is a separate library. The language designer can also define these incremental functions, which can help to solve some performance issues that are harder or impossible to solve in MPS. So I think that's useful. And now Norman will tell you a bit more about the modelix project itself.
So yes, I just want to ground a little bit what Sascha presented, because maybe architecturally it's not quite obvious or it's not quite clear. So starting from this baseline, we all know using MPS on our machine, having some Git backends. What we want to envision and what we provide with this platform we are creating or we're developing is that we can have a way where we can have different cases. So in the second step, this one could say intermediate step, you could either connect your MPS directly with the sync plugin to some MPS instance running somewhere on some remote host or some on your local machine, or use projector streaming everything to a browser, or as Sascha showed, maybe some very custom UI that is created independently, but after all stores in the model server. In this intermediate solution, one could consider, if you're really dependent on Git, well, maybe this is something you need. That is possible, right? You can just load it, use a model client to get the information as Sascha showed, and load it in the model server, right? And then you can either still have your Git in the background, but however you like it. But what we actually think of when we say what our platform also provides in a more different way is that we take Git out of the picture, have the model server as the actual place where the knowledge resides, and the same scenarios can be realized. And then the web apps that run on there can have individual services using the same API Sascha just presented. And then you can do all the same things, but you just have modelix or the model server actually as the knowledge base in this case. And last but not least, just for completeness sake, yes, you run this in Kubernetes, and then you have some workspace management around this to orchestrate and to do all these things. So the architecture the platform provides is quite flexible. These are just some of the cases. You can even add further APIs in between if you want to decouple your web environments from the actual model server, if depending on your consistency needs for the applications you're creating. But just to ground this a little bit in there and to get the idea across, we want to provide a platform that allows to create whatever is necessary for the individual use cases. And for that, in the past, I think it was not always quite clear how to use the platform and what the platform is and what modelix provides. So we have put some effort in the last months in increasing the communication and improving our transparency to the outside. So we had a relaunch on our website, and we created a new documentation, hoping to actually getting the point across better, right? Having some explanations. So it's still in the works, but there's the first version, so to say, is out there. More on this later. We created some API references. So the APIs Sascha talked about, of course, especially for the programmers, are very interesting how they are and how they evolve. So you can reach that on API modelix.org, while the documentation is on docs modelix.org. And in the past, it was not quite clear where the modelix platform goes. So we also created our own new issue tracker where we actually consolidate everything, because we have so many components which are scattered across different repositories and different states. So we try to be better in terms of communication on what we're working on and where we're going, right? So these are just some of the new things we created, we added to the mix. But something that I personally put a lot of effort in is more demos and more samples. So the one Sascha showed, you've seen earlier, you can reach it today. But also we created a sample repository where there are architectural explanations on how the system is set up and what layer is where, and where you can have actually a setup where you have MPS-based meta models and browser-based access to the same models in various types. So here again, I see this as some sort of practical documentation, right? So in the samples, and these are also included then in our documentation stack as well. We did a lot of restructuring, so a lot of the components were not well named. We renamed a lot of things. We organized a lot of things, all in preparation to actually do a release of what we're doing, right? And another thing we did is that we added automated semantic release, at least to our core repository. We want to extend this, communicate clearer what are changes, increase the trust and the understanding of what will come and where we're going, because in the past we haven't been good at that. So having automated change logs based on our commits and stuff like that, I feel like is something that really helps to understand what's happening and whether or not you should migrate to a newer version, what will break, things like that. So this all, as I said, sums up to the point that we are now want to provide further or better stability and planability. So we are going to release the modelix platform as a platform twice a year from now on. So we're actually starting today or yesterday, as you would call it. So the platform is pretty much a collection of all the individual parts and versions, and shows or provides you with a compatible set of all components. So in the past, you had one component in one version, another component in another version, which is quite confusing. This is all to consolidate everything in there. This gives you support for, if you use Gradle, it gives you support to actually just add one line in there, and then everything, all the versions will be resolved automatically. And we see this as one way to further increase the adaptability. We have some samples for that. We put them in the documentation, and with every release, we can then, of course, talk about roadmap. And I think this one is interesting as well. In the past, of course, we looked at things that were immediate. So with this stabilization we have been doing, so all the core components being as stable as possible, especially the storage, the APIs, and the generation of the APIs. We can talk a roadmap and where we intend to go and where we can try to communicate and maybe hear what you guys are interested in. And if you're interested in joining or supporting as well, maybe you can align with us there, right? So these are the I would say, very operational, practical things which haven't happened in the past as much as they might have needed to, but now we're there. And so my encouragement to everyone who's interested is to join us and try the samples we've created and discuss about roadmap. So what we're roadmap-wise doing or have been doing up to now is that we wanted to increase our communications efforts and make this platform release, right? So have this one single version you can actually use, and then you can actually say it doesn't work in that version, and then you can understand or we can understand whether or not we have been fixing things or not. So this platform release with these stable components of a model APIs, the generation of the model APIs or the domain-specific APIs, but also model server, model clients. Right. So this is where we're at. This is today, and with the next increment, we aim to further strengthen also the what we call model QL. Unfortunately, we don't have time to talk about everything we've been doing in the platform, but this is pretty much going to the direction of actually getting the querying model contents and having this not only bulk access to models, but also having a incremental approach. We do have already implementations, but we want to polish and improve it so that they are stable, so that we can consider them actually releasable. Git integration I talked about earlier as well. Shortly, we see and hear a lot of customers actually require this, and we consider this something we would also put some effort in as well. The projectional web editors are here as well. Authentication, authorization, we haven't talked about a bit, but it's also there, but not in a state that is I would say, publishable. And continuing from these, considering we get there, then we can actually talk about, okay, how do we handle the difficult cases, such as language evolutions? How do we get these individual services actually connected? So there's a way to have alternative approaches, have behaviors or scoping or type systems differently, but also if we have a lot of them already, how can we actually add these services up into the platform? Our cloud plugin, you've seen it earlier, it's there, but of course there's a lot of stuff to do as always. And the Lion web integration is here as well. Of course, we started this initiative, joined from the beginning in order to actually, because we feel like the interconnections are the important parts, and sometimes platforms do good things, and we would like to connect them, and we agree that this would be a valuable cause to follow. So this is for that. And beyond that, I guess then we're getting into the territory of guessing, but things we're thinking about and we are already exploring right now to actually make some fundamental good decisions here is the checking, scoping, type systems, but also having graphical web editors like as a given without doing it yourself in your web web tool of choice, right? So these would be the ideas we were having. Of course, we're up for discussions here. We put them regarding what we are releasing now, and so in the context of that, and this is where we're trying to head. And as I said, we couldn't talk about everything. Everything that was mentioned here, I put a star on. We mentioned quite a lot, but it's not. The more conceptual it gets, of course, the less we talked about it here. I wanted to give you some more practical perspective as well. But yeah, talk to us if you're interested, and if there's topics in there that are of interest to you. And I guess this is the best way to get into a discussion. I don't know, pick any topic. It's enough to talk about. We could make an entire presentation just for this one thing, I guess, each of these. And that's about it. I want to keep it short, and thanks for your attention.
Thank you for the nice presentation. I have a question regarding projectional web editors that you have presented. You showed some language rules like scoping and type system. Is it executed on backend or frontend? That's it.
Can you repeat the last part?
Yeah, so there is scoping, type system, etc. And these rules are executed on backend machines or on the web client?
No.
Or both?
Since the model is loaded into the browser, we also need to do all the computations inside the browser. So there's an engine running inside the browser.
And the follow-up, so in some particular cases, some rules can compute like a large amount of data. For example, scoping rules, they can produce large scopes, and the web client can not fit as much.
Yeah, that's usually a problem that you can, for example, in a typical MPS instance, you have like 13 million nodes and you can't fit them all into the browser. I've shown this first prototype that's running inside MPS and just sends HTML to the browser and receives back as a user input. And since we implemented our own projectional editor in Kotlin multi-platform, it's already designed with the use case in mind to let it run on the server side and do the same thing, so that you also don't have to re-implement your type system in scopes, but can use existing ones in MPS. Since we already had this first prototype, in the second prototype, we focus more on running it in the browser, and in the future, we also plan to cover this case of running it inside MPS.
Thank you.
You showed all these custom DSLs in Kotlin. In the second scenario where you have part of it in MPS and part of it on the web, would the idea there be to also run these things like parallel to the current implementations in MPS, or would I generate from there to the type system, for example, from Kotlin type system to the MPS type system, or what's the idea there?
No, the idea is that you have to re-implement everything. You basically just reuse the meta model from MPS, and the models you read and write are compatible to MPS, so you can edit them in both. But the editor functionality itself is a re-implementation. You can see that as a disadvantage, but it's also an opportunity to improve this editor. As we have seen in the previous talk, that there's a need to do that. Yeah, but it's still a research topic, I would say.
Just to clarify, I might not have understood correctly. The scopes and type systems right now, you demonstrated them in the context of the editor, but they're not, conceptually at least, they're not editor specific. So, okay. And so in the medium term, the idea is to be able to run these extension functions, these incremental computations on which this stuff is based, also on the server. So you could potentially run the same type system implementation on the server and on the client because it's Kotlin, multi-platform, blah, blah, blah.
Yes.
That's the idea.
Yes, you can, for example, implement some servers that's running on the server side using the same type system and scopes definition from this Kotlin DSL. Yeah, we have. I said that we have this. We have extracted this incremental computation framework. So you would run that on the server side, including the other aspects, but except the editor aspect. Yeah. But maybe for some reason it also makes sense to run the editor on the server side because you, I don't know, want to render some text or HTML out of it. Yeah.
So, but one direction we also considered is, of course, you can bring this all back into MPS, right? So if you have the editor, which is a web editor, you can also, if you have seen this morning in this example, just bring it back and then you have it in the tool as well. So this is also a direction we've been thinking.
More practical question. So you showed a Gradle plugin that is capable of building languages, right? How close it to replace the built language setup? Can it deal with real-world setups, like if you have stub models, if you have external libraries configured, can it do it already?
I wouldn't say it covers everything that the build language can do. It has the features that we need for our modelix use case, and there's also this problem if you want to publish your library and some project is still using the build language, then you usually need the build language of the dependencies, the build model, and since we don't have one, you can't use can't use them in your project. So if you use this Gradle plugin, then you have to use it in all your projects.
Okay, so meaning for now you're just using it yourself for your MPS-based setups projects, right? But if I would have users using my languages, I would need to do something different, right? I couldn't reuse the same Gradle plugin for the user side, or would it work as well? Because I would have the dependency between the user build model to my languages that need to be present and so on.
Yeah, sorry, I don't really understand the problem.
I think we can discuss later.
But I guess it's important to say it was a byproduct of what we're doing, and it can be of value. So it's in its own library. So, and of course, if that is a use case that is of interest, that can be extended here or can be used for that. But maybe Sergey can say more to this.
Yeah, I just wanted to comment on this a bit. I am using Sascha's library, not exactly the Gradle plugin, but the underlying library in a customer project for building the user models. So the actual RCP is built using the standard build language, but for the user models, we have a Gradle plugin that builds them without the users having to create and update and maintain the build scripts.
Further questions? No? If not,